Hello, welcome to Introduction to Java Programming. In this session, we will discuss operators, which are arithmetic, relational, and assignment operator as part of the part one of the operators. Let's start. In the previous session, we have seen what is an operator, what are called operands, what are different kinds of operators, namely unary, binary, and ternary. Also, we have seen for each operator, what are the two properties which are associated? One is the precedence and the associativity. Let's now understand these operators one after other. So as part of this session, we will discuss about arithmetic operators, relational operators, and the assignment operator. So we have 5 arithmetic operators. And these 5 operators are categorized like this. We have product, multiplication, division, and modulus operator, which are called multiplicative operators. And we have plus and minus, which are additive operators. And these 3 operators, the multiply operators, have high priority as the high priority or precedence. Okay, high precedence, and they have equal priority as well, or equal precedence as well. Okay, that means none of the operators is fewer than the other or superior than the other. They're all having equal priority. Usually, this priority is higher than this plus and minus. And what about the associativity? Almost all operators are left to right associative except assignment operator, right? Yeah, so now what we have to know newly about this arithmetic operators, because these are the very basic operators. So plus these all arithmetic operators basically a binary operators. So binary operators means they require 2 operands to work with. So here all these operators are binary. Okay, so 2 operands are required to do multiplication, division, or modulus, at the same time plus and minus also. So coming to these additive operators, these are having low priority when compared with the multiplicative operators, and equal priority, low, and both of them are having equal priority, and the associativity is actually left to right. So all arithmetic operators are left to right only. Okay, so if at all we have to discuss something about these things, so we need to discuss about this modulus operator and the division operator. So this is the division and this is the modulus operator. So for example, if I say 10 by 3, the output is going to be 3 actually, right? Because 10 is a whole number, 3 is a whole number. Integer division is going to happen. So you are going to get the outcome as 3. Yeah, so if you say 10 modulus of 3, 10 modulus of 3, what actually happens? First division will happen and then a remainder will be there. So what is the remainder? 3 times is 9 and you are left with 1 actually. So this is how this division and modulus operator will work. But there is something which we need to understand about this modulus and division operator, especially whenever we are working with integers. So in Java, what happens? So let me actually show you through a program. So let me have my test program over here. Okay, I have a class called public class test. This is my main class. So here, what I'm doing is I just want to take 2 numbers actually, and I want to do division and modulus. Okay, so how do I take numbers? So there are different ways. Now I can actually make use of command line arguments, which we have discussed already. So I want to take an integer x value. So int x equal to, so args of 0 I cannot do directly because it's a string. Args of 0 is a string. So what we need to do, we have to convert this into integer dot parseInt. So we have to use the parseInt method such that this args of 0 represented int value will get converted back to x. For example, if I say 1, 2, 3, initially args of 0, it is like a string, and the string is going to get converted back to 1, 2, 3. Okay, so then we will actually see y. So y equal to the same thing. So let me actually copy paste this thing. Yeah, so y is aux of 1, the second value. So here, for example, if I give the value, let's say 23 I am giving. Okay, so 23 will be represented as a string initially because aux of 1, then it will be passed to integer like this 23. Now I just want to do some um, division and modulus actually. So for example, if I say int result, actually this is my division result, x by y. Okay, and I just want to print this result. So I'm saying result, and then I want to do a kind of a modulus actually. I want to do a kind of modulus. Before modulus, let me actually do some int p equal to product equal to x into y, x into y. Okay, so let me also print this x into y value, that is nothing but p, and here I just want to make a int a reminder. So reminder is going to be x modulus of y. Okay, so I just want to print this when I am saying r actually. Okay, so and these are simple operators, of course. So for example, it's not 23, let us assume 20. It's just 20. So what is x by y? 123 by 20. So how many times it will go? 6 twos, right? 6 twos are 12 actually. No? So the output is going to be here. So 20, 123 by 20 is actually 6, right? 6 we are going to get actually. So now 123 into 123 into 20. So it will be like 246 and then 0, right? So that's the value actually, right? It's 246 is 123 into 2, and then we will have a 0. And what is the modulus actually? So you are going to get the modulus equal to 3. So this is what the output we are expecting. If I give 123 and 20, let's verify actually. Let's verify this. So I am into the correct this thing. I have a test class here. Let's see. I don't have test class actually. So this I need to save as to my folder actually, which is not this. So I need to go to my desktop and choose this practice Java. And here I have to give test.java. Yeah, this is test.java. Okay, so let me actually now see ls, and you will have this test.java is available. Now let's compile this java c test.java, and we'll get compiled successfully. Okay, so compiler is taking some time. It's simple program actually. So one division, one product, and one modulus operation. Yeah, compiled successfully. And then when I run actually here, I need to pass values. So what I'm saying 123, and I told 23, I will pass actually. Right now, let's see. Yeah, what are the answers actually? So x by y is 6, and product is 2460, and modulus is 3. So this is how the multiplicative operators will work. But yeah, there is something we have to understand with the division and modulus operators. Now this time what I'm doing is try to observe actually. I have given 123 as a first value, but what I'm giving, the second value I'm giving as 0. Okay, so let me actually change over here. What I'm doing here, I am actually giving 0, just 0. My y value is going to be 0. I am converting back to 0 integer. Now what happens? X by 0, 123 by 0. What is happening actually? You are dividing by 0, right? So any number is divided with 0, it is actually going to be infinity, right? It's actually infinity. So do you have a representation for infinity? No. So now what is going to give you is an arithmetic exception. So strictly speaking, it will be like java.lang dot arithmetic exception. An exception object is going to get thrown over here. Okay, so x into y. So Here 123 into 0, any value into 0 is 0, right? It should come as 0 actually, but what is actually going to happen, I will tell you. So x mod y means, first of all, it has to divide. When you are dividing with 0, again it gets infinity, and that is going to be java.lang dot arithmetic exception. So here also we supposed to get java.lang dot arithmetic exception. But now for this program, what happens? Whenever x by y value equal to 0, it will actually, so at this instance itself, the program crashes. At this instance itself, the program crashes because the result is actually infinity, and that infinity has no representation. So what happens? Processor simply tries to find the value infinity, and it is not identifiable. It's not recognizable. So processor simply shuts off. That means your application will get closed. So here itself it will stop. Nothing actually. So no rest of the code, no rest of the code will execute. Okay, that means line number 8 onwards, nothing is going to get executed because it is crashing actually. Let's see. Let's see. Okay, so I'm just saying Java test 123.0. Now observe the output actually. Yeah, nothing is getting printed. So here at this line number 7 itself, see test.main and the line number 7, you can actually see exception in thread main java.lang.arithmetic exception divide by 0. For what? Divide by 0 actually. You are dividing by 0. But because that gives you actually infinity and you don't have representation for integer infinity, so your system crashes. Okay, for example, let's say this is not there. Okay, so these two lines are not there. Now what happens if this will work actually? 123 into 0, so it is 0, but here you will have this problem. You will have this problem, divide by 0, and it crashes. Okay, because I have commented this, right? Now here what happens? X mod y. Here also division is going to happen, and then java.lang.arithmetic exception is going to get thrown, and your R is not going to get printed. But before that, you will have this particular outcome that is getting printed because x is 123 into 0 is actually 0. Let's now understand this one also. Yeah, I need to compile this because I have changed my code. So java c test.java, and if you see here, java test, sorry, I need to give actually the values. I need to pass the command line argument, so that is 1 2 3 and 0. Now you can actually see the output p equal to x into y, that is getting 0. Then when you say line number 13, actually here you can see the line number 13, you have division by 0, divide by 0, exception thread main java.lang.arithmetic exception. Okay, so now what is important in arithmetic operators? Okay, so this division and modulus will actually give you arithmetic exception. So they will actually make your application getting crashed. So you must be careful whenever you are actually using these two operators. So you should be careful. Otherwise, what happens? It may lead to system crash. That means your application crash. Okay, because we don't have representation for integer infinity. Okay, so now you may ask actually, so we are speaking of only integer infinity, right? So what about the floating point infinity? What about the floating point infinity? Okay, so floating point arithmetic has infinities defined actually. So we have something called positive infinity, positive underscore infinity. This is already defined, and we have negative infinity as well. So two constants are defined for infinity values if it is floating point. So when you are going to get positive infinity, for example, so you have the same thing actually. So 123 divided by 0.0. Okay, that is a floating point division actually. That is a positive infinity. And for example, if you say minus 123, so here I am saying minus 123. This is not minus, this is just an example. Yeah, there's a positive infinity only. So here, if we have this minus 123 divided by 0.0, then you will get negative infinity. So these are the constant defined for floating point arithmetic. The same fashion, for floating point arithmetic, something like this also is possible. 0 divided by 0 by 0.0. So this is not positive infinity, rather it is a NaN. So NaN means not a number, not a number. So these things have to be taken care actually. Okay. Yeah, so 0 by 0.0 is not a number actually. It is mathematically undefined value, but for floating point arithmetic, it is not a number. Okay, but if they are integers actually, so there is no decimal points, then definitely either this one or this one is going to be Java.lang dot arithmetic exception. Okay, Java.lang dot arithmetic exception. So if you say 10 by 0, this is going to give you arithmetic exception. This is 10 mod 0, this is also going to give you arithmetic exception. But the same is not the case with the floating point arithmetic. So floating point arithmetic has some constants defined actually. So this is about the floating point arithmetic. So these things have to be taken care, because we are not going to get arithmetic exception here, here, or here. So separate constants are defined for floating point arithmetic, like positive infinity, negative infinity, and NaN. Okay, so this is about the binary operators. So nothing much has to be discussed, because plus and minus, they're straightforward. We can actually use them straightforwardly in our expressions. Okay, so now we will actually move to the next set of operators, that is relational operators. Relational operators. So these relational operators can also be divided into two groups actually. So first group we just say relational only in Java especially, and the second group we actually say as equality operators. See, in C and C++ we say relational only everything, but in Java a separate thing was there for relational. So what is relational here means just greater than, equal to, less than, and less than equal to. So these are called relational. And here we have equality operator, which are nothing but double equal to operator, which is equality, and of course we have not equal to operator. But there was a separation that was given actually. Of course, still you can call all of them as relational operators, no problem. So one point here about relational operators is these are also binary operators. These are also binary operators. So that means you need to have two operands. When they apply on the operands, okay, they will give you the Boolean results. Okay, so there is relational operators when applied, so they will give you Boolean result. Okay, so I will tell you an example actually. So they will give you the Boolean result. For example, I am saying a greater than b. System.out.println of a greater than b. I have two values a and b. So it will actually tell whether a greater than b or not. So that means either you will have answers as a true, or otherwise it's a false actually. Right? So whatever the case actually, a greater than b or equal to b, whatever it is. For example, if you want to see, if you want to see this, so let me actually have here only. I can actually write x comma y values are there with me. Now I just want to print and show you. Yeah, so system.out.println, so that is nothing but pl, both x and y values are there, right? So I'm saying x greater than y, so now what is the answer actually? Okay, so if I give some normal two values, if I give normal values, not 123 and 0, for example, I'm giving 123 and 10. Okay, it's not 0. So x greater than y, yes, it is true. It is true, right? So in the same fashion, if I say system.out.println x double equal to y, so then it is false actually. They are not equal, right? They are not equal. 123 and they are not equal. Okay. Yeah. So when it is 0, it crashes. Yeah. So if it is not 0, then it will not crash. Yeah. Just I'm making the whole program to get understood actually. Yeah. Like that, you can give greater than, less than, equal to, not equal to, etc. Now let's see whether it is giving me true or false or not. Yeah. So let me compile this because I have changed this. Yeah, and when I run actually 123 and I'm giving 10. Now let's see. I'm getting x greater than y. Yes, true. 123 is greater than 10 actually. Right? Then we have x equal to y. No, that is false. And of course, here x into y is 1230 and x mod y is actually 3 because the y value is not 0. So there is no crash over here. Right? So this is some example of relational operators. There is nothing much we have to discuss about relational operators. Whenever they applied, they actually give you Boolean result. Okay. And specifically, one thing I want to tell only about these 4 relational operators. So these 4 relational operators, greater than, less than, and their equal operations, uh, are applicable only on primitives actually. They're applicable only on primitives. We understand what are primitive data types, right? Integers, floating point numbers, characters, and booleans, right? So this greater than, less than, all these are applicable only on primitives except boolean. So you cannot say true greater than false or false greater than true. Okay, but they are applicable on primitives. So for example, you have some x which is integer, you have int x, and int x equal to something, and int y equal to something. Now you can actually say x greater than y, less than, equal to, etc. and etc. Right? On Boolean, they will not work actually. Applicable only on primitives except Boolean, and not applicable on objects. That means references. For example, you have 2 string objects. Let's say string s1 equal to let's say Java, and then string s2 equal to string s1. This is s1, and let's say some s2 equal to let's say it's actually Python. Let's assume. So you cannot compare them actually. So S1 greater than S2, S1 less than S2, greater than equal to, those are not applicable actually. So applicable on primitives, yeah, applicable on primitives except Boolean, and not applicable on objects, these relational operators. Now equality operators. So these two will be there over here. So equality operators are applicable on primitives except Boolean, and also applicable on objects or references. So this equal to and not equal to operator can be applicable on objects and references also. So that means, for example, here I have these two strings here. Here I have these 2 strings. Now actually I can compare them. Okay, so I can actually compare them with equal to. Okay, so now I can say system.out.println of s1 equal to s2. Okay, s1 equal to s2. Actually, this is false, right? And yeah, not equal to. So when I say not equal to, then definitely it is true actually. So s1, then I say not equal to s2. So to be clear, I am just giving a space over here. So like that I can write actually. So this is going to be true. They are not equal actually, right? So that's why in Java we are dividing the whole of relational operators into relational and equality, because equality will work in different way. Equality will work on objects also, because you can compare objects also, whereas these relational you cannot compare. That's why we have divided them into 2 groups actually. So that's about the relational operators. Okay, so now let's understand the another operator as part of today's session. So that is the assignment operator. This assignment operator. Of course, this assignment operator is specified with single equal to. So we can actually write single equal. It's not a double equal assignment operator. So it is having the lowest priority. It's having the lowest priority. Okay, when compared with the multiplicative, additive, relational, logical, bitwise, increment, decrement, etc. So this assignment operator is having the lowest priority, and especially this is actually right to left associative. This is something which have to be understood. Right to left associative. Okay, so now when you say x equal to y, when you say x equal to y, what happens here? y value is assigned to x. Y value is assigned to x, right? So that means x equal to, let's say, 10. So 10 is going to get assigned to x, but not vice versa. So that means what is happening here? From right side, see, from right side, it is going actually from right side to left. So this is the direction. 10 is actually assigned to x, right to left associative. Okay, and it has the lowest precedence. See, that means, for example, if I write x equal to a into b plus c, now what happens? A into b will happen first, and the whole result will get added to the c. Then finally, this whole expression value will get assigned to x. So this assignment operator is having the lowest priority. When everything is done at the right side, finally this value is going to get assigned to x. So this is what actually right to left associative. So very simple to understand. A single equal operator which is having the lowest of almost all operators, which we use generally in expressions, and which is right to left associative. That means right side value is assigned to left side value. Okay, so this is something, and there is one shorthand notation for shorthand, or we can say short circuit notation for assignment operator. Okay, so what is this actually? So this is possible whenever you have something like this. For example, I have something like this: a equal to a plus 10. Okay, and otherwise a equal to a into some b. Okay, and any other operators also. For example, a equal to a and b. So bitwise and actually. Okay, and some a equal to, I can actually have shift operators also. So a left shift, this is a left shift operator, we will discuss by 1. Okay, and one more I will write. So a equal to yeah, let's say a plus 1. Okay, so if you observe this notation, see, this left side value got repeated in the right side also. Okay, the left side value got repeated right side also. So now this can be written in a shorthand way, shorthand notation or short circuit notation. So this whole thing can be written like this: a plus equal to 10. Okay, plus equal to a equal to a plus 10 can be written as a plus equal to 10, because a is getting repeated again, so you need not write a again. So you can say a plus equal to 10. So this one we can actually write as a star equal to b. Okay, and this is actually allowed, this is valid, this is the shorthand notation. And then here we can say a bitwise and equals to b. Okay, so this one can be written something like this. So here we can say a left shift equal to 1. So you are left shifting by 1 actually. Okay, so the first operator will come, then actually the equal operator, assignment operator. So a equal to a plus 1, it can be written like this: a plus equal to 1 actually. So this is what shorthand or short circuit notation. Okay, so this is about the 3 operators, like arithmetic operators. That is very pretty simple to understand. Only thing is, whenever you are dividing by 0, so that is division and modulus operation has certain issue, so that only has to be taken care. And floating point arithmetic, there was no problem, because we have the constant defined, like positive infinity, negative infinity, and not a number. In coming to relational operators, there are 2 types: simple relational, greater than, less than, and their equality things, and we have equality operators. So they were divided into 2 categories, because there is actually a difference. So relational operators only applicable on primitives except boolean, they are not applicable on objects, whereas equality operator can be applicable on primitives except boolean, and of course on objects also. And finally, assignment operator, which is the lowest precedence operator, which has a right to left associative. So hope you have understand. and see you in the next session with the remaining operators, which are actually increment decrement operator. Then we have logical operators, bitwise operators, and finally a ternary operators. Thank you.